So in this chapter, we're looking at solving things called systems of equations that looks like this. We're going to look at the two traditional methods for solving systems of linear equations. First one being substitution. Now here's the steps for substitution. Number one, you want to take one of the equations and solve for either of the variables. If we take the top equation, that's pretty easy to solve for the y. Just subtract 5x from both sides. Then we want to take the other equation, and in place of the y, we want to put what we just found. That is the 4 minus 5x. Then solve that equation. Multiply it out and combine things and subtract. Divide. Once we get one of the variables, we then take any of the equations, like the one that we found in step 1, and substitute that value for the variable. Now the answer is an ordered pair, like a point on a graph. In this case, 1 and -1, which we would write in parentheses. The other traditional method, called the addition method, looks like this. We want to take our two equations and multiply by something in each equation so that one of the variables will subtract out. In this case, if you take a look at the y's, if we multiplied the top one by 5 and the bottom one by 2, then the y's would both have a coefficient of 10. And here is what we would have. Now if we add these vertically, we would get 19x, 0, and 38. Now that is an equation that we can solve, since there's no more y's in it. So finishing solving this equation, if we divide both sides by 19, we get x equals 2. And just like with the substitution method, once we find one of the variables, we take any equation that we've been dealing with and substitute the 2 in place of the x and solve for the y and write that as an ordered pair. Now we want to see what happens when we follow all of the correct procedures, but things don't work out exactly like they did on these two. I'm going to use the addition method on these two equations to show you one of the other two things that you might see. So let's do the addition method. We're going to try to eliminate the y's. That means we need to multiply the top one by 3 and the bottom one by -2. That would give us this. Adding these, we get 0, 0, and 12. Now because all of the variables have disappeared, that tells us we do not have a unique solution. In other words, there's not an ordered pair that fits this system of equations. There are some clues in the way that we did this and what we came out with. The phrase 0 equals 12 is a sentence in math that says 0 is the same thing as 12. And that's obviously not true. And it's never true. And that gives us a clue as to what the answer is. The answer is that there is no answer. Now sometimes the way to say that is to use the word inconsistent, meaning it doesn't work. There's nothing that will fit in those two equations and make them both true. Here's another situation very similar. Following all the regular steps for the addition method, if we multiply the top one by 5, -5, and the bottom one by 1, the x's will subtract out, the y's will subtract out, and look at this. The numbers also subtract out. Now this sentence says 0 equals 0, which is always true, meaning there are tons of solutions. There's a lot of things that will work in this system.